रविचंद्रनचं नाव काय आहे?
Right.
त्यांनी अनम्यूट केले सुद्धा मला येते.
May I request 𝒊𝒒𝒍𝒍𝒆 sir, 𝒊𝒒𝒎𝒏 sir, Janak sir, and Mr. Prem Kumar. Yeah. Right. Good afternoon, everyone. A very warm welcome to all our viewers joining us from across the manufacturing and fabrication industry. Thank you once again for joining us for today's live technical workshop on the right choice in plate cutting, Oxyfuel, plasma or laser, powered by 𝒔𝒆𝒅𝒊𝒂𝒕𝒆 Cutting Systems India. In today's manufacturing landscape, fabricators are constantly under pressure to improve productivity, reduce cost, deliver superior quality, and at the same time meet increasingly demanding project schedules. So one of the most important decisions influencing in all these factors is the selection of the right plate cutting technology. Should you choose Oxyfuel? And when does plasma become the better option? And of course, everyone, a very warm welcome to all our viewers joining us from across the manufacturing and fabrication industry. Thank you once again for joining us for today. Once again, right. So, should you choose Oxyfuel? When does plasma become the better option? And when does laser cutting offer the greatest advantage? These are quick questions that many manufacturers, maybe in the their manufacturers or the fabrication shops or EPC contractors, steel processors and OEMs face regularly. So during this next 90 minutes, industry experts from 𝒔𝒆𝒅 Cutting Systems will help us understand the strengths, limitations, and ideal applications of Oxyfuel, plasma, and laser cutting technologies. We will also discuss practical selection criteria and field experiences that can help manufacturers make informed decisions. So before we begin, I encourage all our participants for today to submit their questions through the Q&A box. We will take up as many questions as possible during the Q&A session at the end. So to begin today's workshop, as we say, it is my pleasure to introduce our first speaker, Mr. 𝒊𝒒𝒂𝒍𝒆, Joint Director, Sales, Marketing and Services at 𝒔𝒆𝒅 Cutting Systems India. He brings extensive experience in industrial cutting solutions and customer applications. Mr. 𝒊𝒒𝒂𝒍𝒆 will start today's session with an introduction to 𝒔𝒆𝒅 Cutting Systems, providing insights into the company's global expertise, technology leadership, and its contribution to advancing cutting technologies across industries. So, ladies and gentlemen, please join me in welcoming Mr. 𝒊𝒒𝒂𝒍𝒆. Over to you, Mr. Prashant.
Am I audible?
Yes, sir.
Thank you. And thank you, Subhajit, for organizing this for our dear participants. And gentlemen, it's my privilege. And I add my word of warm welcome to you all. And in today's environment, you sparing out, almost 1.5 hours to understand this topic in little depth puts up an immense responsibility on all of us. And there are panel of speakers. I will just introduce 𝒔𝒆𝒅 to you. and quickly run through, the how 𝒔𝒆𝒅 India and 𝒔𝒆𝒅 globally is placed and what services we offer in India. And then we would immediately jump to the technical topic of the day, where we have our three members who are going to join: Mr. Ravichandran, Mr. Prem Kumar, and Mr. Janak Bua. So again, a warm welcome. Thank you very much for joining. And this is how 𝒔𝒆𝒅 Cutting Systems is a owner-based company and presently owned by Mr. Stefan Messer. Last year, he was on invitation of the Prime Minister in India, and that's the wonderful picture we clicked for him. He came after a long period to India, and that's their office in Ban Sudan. As far as the 𝒔𝒆𝒅 world is considered, the group of companies that they are into, majorly they are a prominent player in China, Vietnam, North America into the industrial gases. So 𝒔𝒆𝒅 Gases is one of the flagship company with them, and they are into many industrial gases along with the CO2 gas and many other things related to gas. Many manufacturing locations and gas separation units worldwide. Another company which 𝒔𝒆𝒅 Group has is the Spectron, which is into the gas control systems. These are panels, high purity regulators, the pipeline systems and the systems which are required for gas chromatography, and these type of complete installation and high precision gas equipment range, which is generally called the high purity ranges, right from industrial 4 purity up to the 8 purity level of gases. Everything, equipments related to that and systems related to that are covered in Spectron. 𝒔𝒆𝒅 also has a gas division, that is, we call it the OBU. And similarly, there is a US company called as FlameTech, which is also owned by 𝒔𝒆𝒅, primarily into the gas equipment business. These are regulators, torches, flash wrecker arresters, heating torches, cutting systems, primarily based on gases. So the manual systems are covered under the OBU, and the US company for the same is FlameTech. And then we come to the platform today for 𝒔𝒆𝒅 Cutting Systems, the group, which is primarily into the gas equipment as well as the cutting machines. And when we talk of the thermal cutting machines, we all know they are primarily the Oxyfuel machines, plasma machines, and now the whole world that talks of are the laser cutting machines. So we will run through the details, over the upcoming slides. How are the MS's global production locations? Menominee Falls in USA, Sao Paulo in Brazil, Rosenstadt, Germany, from where the head operations are also done, Kunshan in China, and then the latest and the youngest one is the Coimbatore plant of 𝒔𝒆𝒅 India. And these are the number of machines. They are approximate machines which are working as of now, and cutting across the continents tons and tons of steel plates to make engineering component. There are wide dealer networks, service networks across the world which are placed. And just a small story of 𝒔𝒆𝒅 India operations: started in 2008, expansion in 10, another expansion in 11, and shifting to the new facility in 2013. And after that, another expansion into the laser plant, which was done in approximately 2017-18. And I take this opportunity to extend a warm invitation to all of you. Recently, Subhajit has been to this plant, and I definitely vouch for that. In case you are traveling on a holiday to Ooty or you are on a business visit in Coimbatore, to make a point that you have some 3 hours spares, and we would arrange a plant visit for you. And definitely you would be happy to see some systems and operations in place for this facility in Coimbatore. This is just opposite the Larsen & Toubro Limited in the place called Malai Muchampatti. We have a complete gas cutting range as well under the same company, which is right from cutting torches, regulators, flashback arresters, gas nozzles, the gouging torches, the steel mill torches, and there are many more systems. When you want to install, these days, the engineering companies do not want the gas cylinders. The gas cylinders that are the gases that we use in our plant. We talk, we call them, let us say, oxygen, acetylene, LPG, argon, shield, nitrogen, helium, now hydrogen. Even all these gases, the the space the cylinder occupies are very, they occupy important space in the plant. At the same time, there is a lot of movement of cylinders which inhibits the movement of the components. So as far as the safety is considered, more and more people are opting that the gas cylinders to be outside the plant into a controlled place. And at the same time, there would be a pipeline system running through the plant, and at the tapping points, you would be drawing the gases as per your choice and as per your pressure and setting requirement. So we do the complete pipeline system, which is an engineered one, along with all the safety process and regulations in place. There is a bunch of gas safety training programs that the organization, our team conducts. I strongly recommend you that if you have these gases and equipment in your plant, engineering gases working, do write to any of the address or contact points in LinkedIn, website, email address that you have, and we would be happy to depute our expert trainers to conduct the free training program at your site or your plant. It's a very designed training program, and definitely will help you to increase the safety levels in your plant. Gentlemen, now we come to the basics of the cutting process. We all know we have been seeing a cutting torch right across, many decades or everywhere, right from a small street shop next to your place, which is doing maybe a flame cutting. And then we have seen manual plasma cutting machines, and now we all talk of laser. In details, Mr. Ravichandran will take us through that. But as you all know, that in a gas cutting process, which we call as oxyfuel cutting process, it can be the manual, the cutting torch that you see in the hands of an cutter or an operator that we call, and you would see nozzles and a flame out of that nozzle. This flame would be either of LPG and oxygen, or it would be acetylene and oxygen. This flame is primarily used to heat the plate. Only MS can be cut by this process. So it heats the plate. The plate runs, gets heated red hot, that is 500 degrees Celsius, little more hot, yellow, it is 700 degrees Celsius, and almost at 800 degrees Celsius, the operator presses the cutting oxygen lever. Or in a machine system, the cutting oxygen starts, which comes right through the center of the nozzle, and then there is a cut through the MS by the exothermic process. The melting happens, means there is an ferrous oxide formed. The ferrous oxide melting temperatures are lower than the nearby melting temperature of the steel plate, which is around 1200 to 1400 degrees. And these oxide immediately melt and make a cut part. You maneuver your hand or the machine, and the cutting happens across this place. It's a slow process. It is most economical, but at the same time, you can cut up to 300 normally, but you can go up to 1200 slabs cutting as well by the same process. Very ancient process, slower, but it has its own constraint in terms of speed, in terms of material. So when you need to cut stainless steel, necessarily plasma was the process. So in a plasma process, we produce the plasma, which we call as the third stage of matter, where the plasma gas gets ionized, and by the concentrated pressure off from the back of the nozzle, we again divert or direct the plasma flame onto the job, and it cuts through. Here it can cut up to 160 for very fast process, very good cut quality, but it requires a little investment because there would be a power source, and then there would be the machine system. It also has manual system where you do manual cutting, but it would have limitations because of the high intensity of the process, the flame, which is more than 3000 degrees Celsius. So this was primarily the dominating process for increased productivity, and when stainless steel comes into picture. Then came laser. In laser, we all know now laser has the widest engineering application, right from doing a small treatment of, through laser into some sort of, disconnections, or in some sort of some problems in your eyes, the laser can be as precise there, and it can be as high even to cut your 10 12 plates. So in this, we have a resonator, laser resonator instead of the plasma, and the rest of the process remains same. Whereas the use of laser for cutting manually are not yet done, very, very limited somewhere. But yes, it is used for manually also for the welding process. So laser has lot of application there. More detail comes up in the slides ahead, but as you all know, that we have the complete range of all three systems. So when you talk of Oxyfuel cutting machine, you talk of plasma cutting machine, you talk of laser cutting machines, we are happy that we have all the solutions for you. So we would give you the right choice. It is not that because we have laser, we will only push you the high investment laser, or we, if we would. So here with Messer, you have one good option is that we are there into all three processes and looking at your jobs, looking at your productivity requirement, thickness requirement, finish requirement. Our team of experts in application engineering, headed by Mr. Ravichandran, can give you the right choice, cost calculations for your components in each of the process. And then you can take a wise decision looking at the investment as well. So there are complete ranges, right from a small air blade, which can cost 20 lakh rupees, up to the largest machine as per your requirement can be, given to you. As we all know, in plasma, there is the basic one is the air plasma. Then we enter into the mid segment where we call it oxygen plasma, where we are using oxygen as a plasma gas. And then comes high definition plasma, where we use mixed gases and the thicknesses increase, speed increase, cut quality improves. And these are high-end applications. As far as plasma is considered, we have two major partners for the plasma source, Hypertherm from USA and Kellberg from Germany. So we provide the consumables, spares, and everything, the genuine consumable spares required for this, along with the power sources as well, individually as well, and along with our machines. We also do retrofit solutions, means you have an old machine, either Messer or some other make, but you don't want to discard that machine. You don't have capital budget, you have only revenue budget. So we can always work along with you and improve the productivity of this machine, improve the quality of this machine, change controllers, because many times the frame and everything are intact. So it can be upgraded. Suppose you have used it for 6, 7 years, 10 years, 12 years, and you feel that it needs an upgrade in terms of productivity, quality of cut, higher amperages, so thickness can be improved. All that can be done through our retrofit program. Just some similar examples we have done across. Every year we do approximate 30 to 50 numbers of old machines retrofit for our customers. Messer has a wide range of service team, because these are very mechanical systems working under harsh environment. The parts, the components need continuous improvement or services. So we have AMC programs, service programs, retrofit programs. So there is a whole lot of team along with our LCM managers who help you to improve your or rather reduce your per meter cost of cut, improve your machine performance. Always do write to us. If you still find that there is a gap somewhere, you are already a Messer customer. So do not hesitate, sir. Please write to us and we'll see that we correct ourselves and provide you the best services. Just few big names on the radar. Whatever I could include, many of them, we are humbled that we have all the major brands of the country which are into big fabrication on our customer list. And in the export region, because this region also covers the complete Middle East region, we have many big names from the Middle East also as our esteemed and honorable clients. So there is a relative selection of the process in terms of thickness, precision, cut quality. But I leave it here. From here onwards, Mr. Ravichandran will take you through the details of the process and how exactly we would do the selection. So thank you very much. This was my part. Over to you, Subhajit.
Thank you. Thank you so much, Mr. Prasad, for introducing us to Messer Cutting Systems and and sharing the company's vision of delivering advanced as well as diverse range of solutions the company offers to the industry. And of course, I had to accept that when I visited your facility, I think not even 15 days back. So I was thrilled to witness the kind of work you were doing, the kind of R&D happening, the employees, the resources. When I spoke to each one of your individual who are working there, thorough professional. I'm really overwhelmed. Mr. Ravichandran was there, so I could meet him there. So thank you once again for the opportunity. So viewers, now that we have an understanding of what Messer does or Messer's expertise, let's move to the central theme of today's workshop. that is, selecting the right cutting process is often a balancing act between quality, productivity, material thickness, operating cost, and future business requirements. So to help us understand these critical selection parameters, we move to our next technical session, we can say. So our next speaker is Mr. Ravichandran, who is the DGM Application Engineering and ISD at Messer Cutting Systems India, who will speak on the topic selection parameters between oxyfuel, plasma, and laser. Mr. Ravichandran has extensive experience in thermal cutting technologies and has worked closely with customers across various industries to identify the most suitable cutting solutions for their production requirements. So in this session of Mr. Ravichandran, he will compare the three major plate cutting technologies and discuss key decision-making factors. Please welcome Mr. Ravichandran. So you have to unmute yourself, sir. Sir, you have to unmute yourself.
Yeah, sorry.
Right.
Thanks, Abhijit.
Yeah.
Thanks for the opportunity given to me to express what is happening in the industry right now regarding thermal cutting technology. Let me share my screen.
Please do that. Yeah, it's visible, sir. You can go ahead.
Okay, just a moment. Yeah, I'm audible now?
Yes, sir.
Yes. Thanks again. And I will talk about the three technologies, not on the working front, and I'll just speak about the benefits, limitations, and capabilities, so that that gives you an understanding of what technology can be suited for each one's application. Because same application can have different parameters with which you view it. So with the insight what I am going to provide on the capability of the cutting technology, you can take a decision. And then apart from that, following that, I will also speak about the solutions Messer provides for each technology, and an overview of the products we offer for cutting. Okay, and now going to the cutting technology, we have got three types of thermal cutting technology. One is the plasma cutting, which uses electricity, and then the flame cutting, we call it oxyfuel, where you have a fuel gas and oxygen, which is used to heat the plate and then cut it. Then you have the latest one, laser cutting, which uses light, monochromatic light to cut plates. So one big thing is this is removal of material. In fact, whatever in all industries, when machining is done, material is removed to bring out a desired form. And this also works in the same manner. But the only thing is here, the tool with which we are going to cut doesn't touch the part, so there's no physical contact. And since that, then we use flame or electric power or light to cut the material. So it's not just a tool and the material. All other factors like what you can say, your gas involved, the power involved, and the height of tool with the plate, everything controls the quality of cut. Apart from the basic quality of each technologies. So like the same screen what Prashant showed up, I'll not talk much about it because he has explained in depth. We have got the oxyfuel, plasma, and laser. And the main thing is with oxyfuel, you can cut up to 300 mm, and in cases if you want more than that also, we can go up to 450 mm. And when you cut closer, like you have a hole, then if the thickness of material is 10 mm, you can only make a minimum 20 mm hole. When we are talking of minimum 10 mm hole, it means a perfect round surface can be got by 1:2 ratio of the plate thickness. Whereas in plasma, we can go up to 120, And with a very high definition plasmas of 800 and 600 amps, we can cut up to 150, but that will be a very edge cut. But generally up to 120 we can cut. And then hole ratio is maximum 1:1. So if you have a 10 mm plate, we can make a minimum of 10 mm hole. That even with the high definition plasma, with a well-tuned and programmed machine which carries the plasma tool. So that is for plasma. And then for laser, it's like hole ratio can be as low as 1:0.7. And in some rare cases, it can still go down. And then the thickness is restricted. So maximum of 30 to 40 mm. And main thing is fast cutting, low heat affected zone than compared to Oxyfuel. Plasma is still lower than Oxyfuel, and laser is still lower than plasma. So these are the differences between the three cutting technologies. Then this is a video, but this is a bit old, so I'm just skipping it. So the thickness, we always have a bubble diagram. So what happens is normally laser is very good till 25 mm, and then plasma is up to 150 mm, but still the best quality is somewhere around 80 mm. And then above that, Oxyfuel. Now, if you see, that's on one axis, you see this bubble, and the other axis is your curve. The curve is when you cut, you have the material which is blown out. That is very low when you consider laser. So the bubble on the X direction, the horizontal direction, is limited to hardly around 0.3 or 0.4 thickness, while plasma goes up to 3 mm, and Oxyfuel, in some cases, it goes up to 4 mm, up to 200 mm thick plate. Beyond that, the curve itself goes up to 6 mm, 4 to 6 mm. That means what I mean curve is when you have a plate and you cut it, the portion of material which is heated and blown away, that is called the curve, the material where we lose, or after we cut, we don't have that material. So that's on the curve, on the x-axis, on the thickness on the top direction. And so up to 25 mm, you can have a better finish. And because of the advent of high powers, the curve still goes beyond that up to 40 and 50. But still, the quality is not as good as 25 mm. So that's why we have put a different color to that. So it is developing fast. Laser is fast developing when you compare the technology with plasma. And Oxyfuel is already a proven one, and not much for development to happen on that. And now comparing in terms of cutting capability. So thin sheets up to 12, we would say that plasma is the, laser is the best suited. I just put a laser pointer. Laser is the best suited, then plasma is good enough, but Oxyfuel, when it comes to thickness very less, its productivity is not there. But when the thickness is from 16 to 25, plasma is best suited, laser is also good, still Oxyfuel is not productive. But above 25 or after 50, Oxyfuel is the best solution, and plasma is good, but laser has very limited application. So only up to 25, laser is good. So this is the, what you can say, mantra in terms of capability of the technologies. Then curve, like what I told, like for Oxyfuel, we go up to 3 to 6 mm, whereas in plasma, it's maximum 4 mm. That even when you go for higher thickness. But laser is 0.1 to 0.5. It means more accurate, moderate, and less accurate. That's how we can define. And edge quality is good for plates up to 16. Good finish, very good surface finish, but slight taper is slightly there, which I will explain it to you in the forthcoming, where the taper is also divided into 3 types of plasmas. So I will talk to you about that. And here edge quality is poor, means it will be straight, but still when on the corners, it will have a glowing effect. And bevel capacity, good with plasma, limited with laser, because we have limitations with stainless steel. Then coming to productivity, Oxyfuel is very low because the cutting speeds are low. Plasma is high, laser is high, but considering thickness of material, if the thickness of materials plate is bit higher than 10 or 16 mm, then plasma is only the technology which can cut material with high speed so that the productivity is increased. So it's a slight overview on comparison between the three technologies. Now I will talk to you on specific or you can say cutting capability, cutting speed, productivity, that way on different technologies. I will not be comparing Oxyfuel henceforth for each and every comparison, because when you have a thick plate which is thicker than 50 mm, you can only cut with, or it's best to cut with Oxyfuel only. So most of the comparison happens when you have a plate cutting between 16 mm and 50 mm. So that's where we want to have a real comparison. So I'll be mostly comparing between plasma and laser, because those are the faster, high productive technologies which are used for cutting. So now, cutting capability wise. So I've just having the chart only for quality cut capabilities, not for what you can say maximum cutting capability. So when you have plasma, you have cutting without dross. This blue line shows the cutting without dross, and above that, still you can go up to this for quality cut, but you may have a slight dross which is easy to remove. So, and I have classified the plasma into air plasma, oxygen plasma, and the high definition plasma. That's how plasmas are classified, by virtue of how they are cut and what type of gas they use and the technology. So we have got three types of plasmas. One is air plasma, oxygen plasma, and high definition plasma. So air plasma is up to 125 amps, and the best quality you can get is up to 16 mm over here, and maximum you can go up to 25 mm. And then beyond that, you can still cut, but you will not have a quality cut. And with oxygen plasma, which have capability up to 200 amps, the best quality will be at 20 mm, even though maximum you can go up to 30 or 32 mm. And then comes the high definition plasma, which starts from, say, around 150 amps usage till say around 600 amps. And that we can have a good quality cut of, say, around 40 mm without dross, and you can still go up to 50 mm with a minor dross. I don't want to talk about the very high amperage plasmas in this two things, because these are only used when you have very extensive and higher thickness cutting. So general plasma usage will be in this category. Like they will start from 300 amps and up to 450 amps. So with 300 amps, we can cut up to 30 mm, very good quality finish, and the quality also is good up to 50 mm, but still you will have some feed marks, but acceptable with slight dross. But with 400, 450 amps, you have a good quality of 30 mm and 50 mm. Okay, 30 mm will be without dross, fine quality. So this is the plasma cutting, and on the right hand side we have got the laser. I've just kept the scales identical, though. So you see the 70 mm is over here. So when you compare these two graphs, the cutting thickness capability is of plasma itself looks much better than the laser one. So you see, this is the power. So even when you have a 20 kilowatt, your butter finish is only up to 20 mm, whereas higher thickness is up to 30 mm, 30, 32 mm only. And then when you go beyond that, maybe 40 or 60, which I think in India, we have never experienced. Maybe this year we will be introducing the 40 and the 60. And in that case, we can go up to 30 and 40 mm on a butter finish. I'll show the finish how it will be, what we call it as a glossy finish. I don't want to call it butter finish, but it's a glossy finish, which will be more similar like plasma. But beyond that, in this area, whatever you cut in this area will have feed marks, but acceptable. There will not be any surface variation. So it's good. So it's like, but still, when you want to have a 25 mm and investing a 30 kilowatt, it will be high on investment. So the cost of investment with the capability, if you really see, plasma is good for application up for 25 mm to 50 mm. Whereas here it's good up to say 10 mm or 20 mm thick cutting. That's first from starting from laser cutting capability. Then going to productivity. Productivity is one is we have understood the thickness of plate that can be cut. Now the productivity. So on the left you have the laser cutting speed. On the right you have the plasma cutting speed. So my first statement is 1 to 6 laser is very ideal. So I'll just take up to 1 to 6. The speeds are about 3000 millimeters per minute. So when you go cut at 2 mm, your speed is somewhere around 5.5 or 6 meters per minute. Whereas for a laser plasma, it is 3 or 6 mm, it is only 4 meters per minute. So productivity is low when you have plates below 3 mm or 6 mm. It's low in plasma than in laser. Laser gives a very good productivity. But as the thickness goes beyond 6, it goes to 10. Both are like 10 to 16. Plasma and laser are similar to each other. When you increase this laser power, it matches with plasma. And beyond 20 mm, plasma is more productive. So here, if you see, you don't have any thickness. I'm not going to talk about PMX, air plasma or oxygen plasma, because I told up to 20 mm, they are very good. Beyond that, you have the high definition. The cutting speeds are much, much higher than what you get in laser. So when you have a higher thickness cutting, above 25 up to 50 mm, the plasma gives a higher productivity. But whereas from 10 to 16, it depends on the volume of cutting, whether it is you have to choose plasma or laser. It is not just volume. The intricacies, like if you have a very intricate jobs, then laser is better. If it is normal fabric cutting, which is needed for fabrication, then plasma is better. So that's how. One is productivity, one is capability, I've told, one is productivity, the other one is the finish, which I'm going to tell next. So these three factors should be considered when you select the technology for cutting. One is Oxyfuel. We don't have to dispute between Oxyfuel, plasma, and laser, because Oxyfuel is a different segment altogether, the cutting capability. That is, if you have plates which you want to cut above 40 mm and above, or 50 mm and above, generally, maximum, the volume of cutting in that segment, Oxyfuel is the only solution. But when you have for below 40, then your choice goes to plasma. Then 25 and below, choice goes to laser. So it's like depending on the volume of the plate thickness or segment what you are cutting. That's how we have to select. So now coming to individual capability, finish wise, in laser, I've told you this is the maximum quality cut, and this is the maximum cut. So generally, people will not cut in this segment. So whatever we are interested is below this segment. So if you have a 20 kilowatt, if I'm typically talking about mild steel cutting with oxygen. Okay, we have two types of cutting technology for mild steel. One is generally oxygen, and because since the high powers have come, now cutting with air also is taking popularity. So that also I will explain. But if you want to have a good finish, so below this blue color line, the finish will be like this, glossy finish. You will have no feed lines. It will be very smooth. But beyond this, up to the quality cut, you will have visible feed lines, but the visibility will be there, but the surface will be smooth. And the taper will be within 1 to 1.5 degrees or 2 degrees maximum. And beyond that is the maximum cut where you have deep feed marks and a rough surface, which is not a desired cutting quality. So we should always look at whether you need a glossy finish or just a quality cut which can be used for fabrication. So this is how the cutting capability of mild steel with oxygen. And now I'm going to explain the other one also. There, I've told you oxygen, you get a very good finish, a glossy finish. But with air, you get a very rough finish, rough look. It's not a glossy finish, but a good look with feed mask, well visible feed mask. So on the left is the same graph which I showed, but I have shrunk it on the height to match the curve on the left, on the right. So on the right, you have the cutting speed of mild steel when you cut with using air as a medium of cutting. So here what happens is the cutting speed multiplies itself, though the surface is low. So when you have a 6 kilowatt, this is what it is, you can cut maximum up to 6 mm. But the speed of cut is much, much higher. So you can say, so from 1 to 3 mm, you can have cutting without draws, and your cutting speed is very, very high. You can reach 1 mm, you can go up to 45 or 42 millimeters per minute, 42 meters per minute. Whereas 1 mm with oxygen, you can go only up to 9,500 millimeters per minute. So it goes up, the speed goes up by 4 times. Your productivity increases by 4 times. So only when you are acceptable, like you are accepting a finish where you don't have a glossy finish, it's okay. I can have a rough look, which I'm going to use it for a fabrication. Then we can go for air cutting. Air cutting, but the thing is, the cutting capability also is limited. So when you see what's for 6 kilowatt, I'm taking the first curve. 6 kilowatt, we can go up to 16 mm quality cut on with mild steel with oxygen gas. But when we go with air, we can cut only up to 6 mm. And similarly, when you go up to this is the curve which is for 12 mm, you can go up to 10 or even 12 mm quality cut. But when you go to when you cut with oxygen, you can cut up to 25 mm quality. So that's the difference. Limitations are there on the thickness you cut, but you have a tremendous increase in speed. Your productivity increases when you cut with that. But since you are going to use a higher power to cut a lower thickness, your investment has to be higher upfront. But when you since the productivity increases, then you can what you can say the ROA can be justified. So it all depends on the volume of production and the quality of the cut you need. That only decides whether you want to cut with air or you still have to cut with oxygen. So that's a big thing which deciding factor if you want to cut with laser. Then plasma is the same thing which I showed earlier, but the maximum blue line is for the maximum cutting capability. So normally it can go up to 120 mm with 450 amps, and here 150 mm for the 600 amps plasma. But this is a very rare used plasma. Generally, up to 450 amps, we can cut up to 120, or with 300 amps, we can cut up to 80. But this is a very coarse cutting. The quality cutting will be 40 mm for 300 amps and 50 mm for 450 amps high definition plasma. And if you really see, if the best part of plasma cutting is you have a smooth surface without any feed lines, visible feed lines, but still, since the curve is will be 1 mm, 1.2 mm to 3 mm for generally used thickness, and for maximum thickness it will be 4 mm. The volume of material blown out is higher. So what happens is on the edges, the bottom of the edges will be slightly rounded. That's the only disadvantage. But still, the cutting quality will be good. The surface will be smooth. And while we cut with air plasma, the taper will be between 4 to 6 degrees. Whereas the taper with oxygen plasma, which has got a capability of up to 200 amps, the taper still comes down like to 3 to 5 degrees. And when you use a high definition plasma, that's where when people for who intend to have a better cutting quality for fabrication, they normally use the high definition, which they use up to 40 mm or 50 mm. The taper will be as less as 2 degrees also. So depends on the selection of plasma. You can have the taper on the outer surface of cutting. So on a relative selection, when you have a thick plate cutting, there is nothing to dispute about. Oxyfuel is the best solution. And when you have plates from 25 to 50, it's better to have plasma. And then from up to 25, if up to 10 or 12 mm, laser is a better solution. From 10 to 25, you can have a mix of either laser or plasma. Because the justification depends on the productivity you think, or the quality you aim to, or the investment you want to make upfront. All these factors, they are not complementing, but they are important factors which you have to consider, which should be weighed more than the other one. So that decides on the process to be selected. So just to laser is actually slowly dominating the market, but still to give you an insight on the advantages of plasma over oxyfuel and laser, I'm just putting you a few points to just remind you the benefits of plasma. Plasma always have a better cut quality, okay, and productivity is higher. The cutting speeds are anywhere between 2.5 meters per minute to 4.5 meters per minute, and lower cost of cut per length. This is regarding high productivity when regarding oxyfuel. When you consider against laser, again higher productivity for thick plates, say 10, 16, 20, 25, productivity is higher than laser. Then various, like using the same torch, you can same plasma, you can have a wide range of application. And considering the investment, plasma, when you have consider plasma, the investment is lower, at least 1/3 the investment of laser. So the lower capital demand for plasma, but higher productive. But when you have when you need high precision, then laser becomes the solution. So that's how we classify. Then this is just a thing which shows the capability in terms of cutting. So laser, this is mild steel, stainless steel, and aluminum. So anywhere between 0.6 mm up to 60 mm, you can use laser. And then this is laser means 60 means the higher power. I'm talking of 60 kilowatts. So it's just a bandwidth to show the operating thing. And similarly, plasma, and then the oxyfuel. Oxyfuel you can consider only for mild steel. So between plasma and laser, how do we choose? So one is the workpiece or the plates which you want to cut, the part the output you want to get. If it has got simple lines, if you're just cutting a square with 4 corner holes or something, or just making a cutout, then it's a simple cutting, plasma is better. When stricter tolerances are there, small holes have to be made. When you consider plate to hole ratios to be very small and precise, we have a very intricate surface, then laser cutting is better. So thickness wise, you have more on 25 mm, 30 and 40, plasma is the best solution. When you have more plates up to 6 or 10 mm, then laser is the best solution. So you have a slot or a inner contour, then laser is better. Whereas if the qualities of the inner slots are not good enough, then plasma is a better solution. And refractive materials, you talk about plasma, stainless steel or aluminum. Plasma doesn't have any effect. It means like whereas with laser you have back reflection hitting the laser, so you have to be very conscious while you cut reflective material. But that's not the case with plasma, wherein it doesn't have any effect while you cut refractive material. And cost of cutting is low in laser, but investment is higher. Plasma cutting, cost of cutting is slightly higher, but investment is lower. So this way and that way, the technology works. So pros and cons. Oxyfuel, straight edge, advantage. Then you have a higher thickness. It's better to have oxyfuel. And then without piercing, you have more on edge cutting. It's better. Disadvantages is only used for mild steel. You cannot cut stainless steel, aluminum, and other material, non-ferrous. And it has got very slow speeds. Cutting is nothing more than 500 millimeters per minute. Normally, it will be 150, 250 when you cut higher thickness. Then if you're cutting thin material, say 3 mm or so, then it will wrap up because heat generated is more. So heat affected zone on the plate is also more. And considering plasma, when you consider plasma, it can cut all electrically conductive materials. We don't talk about any non-conductive material also. It's all we are talking about steel. So mostly it is all are electrically conductive. And then cutting speeds are higher. Then ability to cut higher thickness also. Disadvantages, the curve is slightly wider. It's so just if you see, this is the curve. This is what you get for oxyfuel, and then this is plasma 1.2 to 1.8. Then laser is very thin, 0.2 to 0.4. Sometimes higher thickness you get 0.5. So higher power consumption because the power is used to ionize the gas, which in turn is going to cut the material. So power consumption is slightly higher, and surface quality is always better for plasma. And then for laser, advantage when you want high precision or clean cuts, laser is good. And minimum curve, so material utility or plate utility utilization is better than other two technologies. Disadvantages when you have a demand to cut thicker material, it's really tough. And then it's more sensitive. laser cutting is more sensitive. What it means is many factors like the power, the speed, the gas pressure, flow, then purity of gas, then the cleanliness of the optics, and exhaust system where you take off the fumes. Everything has to be good. And all the other factors, like what I told was the power, speed, gas pressure, gas flow, purity, and more than that, the focus length, height, all those, and the composition of the material also. All these play an important role on the cutting quality and speed, and they are more dependent on each other. So it means like you just reduce the air pressure or increase the air pressure, the cutting will be better. It's not that way. You change one parameter, then you have to fine tune all the other parameters. So that's a big disadvantage when you consider laser. That is not so with plasma and Oxyfuel. They have a clear database wherein the air pressure is set, speed is there, only these two. But here, like all the other things, a slight change in the parameter, then the cutting quality goes off. But if everything is good, the cutting speed is good, speed is better, the quality is better. Since it's got a very small curve, you get high precision cutting with this. So when you have a very small slot or inner contour, make a small hole, laser will be the best solution. So this is about technology. Now talking about why 𝒔𝒆𝒄𝒄𝒄. So 𝒔𝒆𝒄𝒄, though we use all the three technologies, our equipments, we say, are world class, which is of global standard. One thing is we have a global presence. All our designs are global designs. Whatever we make here for India is also used in the US or Europe and Asia Pacific. And then all the products are global products. So there's nothing called a product for India, a product for Middle East, product for Europe, like that. So all benchmarks, all designs are uniform throughout. And we have all the features for vertical as well as bevel cutting in all the three technologies. Then all our machines are controlled using our own controller, which has been perfected over the years. And apart from the cutting machines, all the allied products like your cutting table, filter, to take the fumes out, all are supplied under one roof from 𝒔𝒆𝒄𝒄. Then we have some supporting tools like marking, scanning in the sense, scanning the plate automatically and deciding the full area, how to cut. So that all those are available in our machines. And most importantly, the CAM software to use to cut is also from the 𝒔𝒆𝒄𝒄 portfolio itself. So we have everything under one roof. And IoT has become a part of life now. So we have monitoring solutions to see the effective utilization of our machines and what is being cut at what time. So real-time monitoring with the real-time feedback also. And then apart from that, we have the material handling solutions for automating all these machines, right from storage to feeding the machines, and then after feeding, then removing the cut parts also. So everything under one roof, and that even under a global roof, is what 𝒔𝒆𝒄𝒄 is. And our product stands testimony for all these factors. Now, I talked a lot about the technology, and I will breeze through the products where these technologies are used. So first, we have the plasma and Oxyfuel machines. So the lineup is like from air plasma up to a high definition plasma. So air plasma is where you have a cutting taper of around 4 to 5 degrees. 3 to 5 degrees. And those are mainly used for areas where the taper doesn't affect you much, and you don't have to invest more, like the PEB industry. And then for the fabrication industry, where the edges are not so important. So the starting is our smart blade, which is a machine typically made for ducting application. So it's a very 3 meter by 1.5 meter, which can be it's a drop and cut machine, which can be taken to places where we have to manufacture the ducts, then the Terra blade, then the Trophytherm, then the high definition plasma used machines like 𝒔𝒐𝒏𝒄𝒄 and the Element. So just to have one slide on each machines. The first one is the smart blade, like I told, this duct cutting machine. And then the next one is the Terra blade for the air plasma application. So very limited sizes, lengths of cutting lengths of around 13 meters maximum, width of around 3 meters, 2.5 and 3 meters width can be cut in this. And only this for this plasmas up to 150 amps can be used. So mainly this is suited for air plasma. Then the next is the Trophytherm. This is, I would say, more suited for the fabrication industry, not heavy fabrication. So this is where you can use plasmas up to 200 amps, mostly the air plasmas, and also a few high definition plasmas also. So we have machines. These are more configurable machines. All our machines are highly configurable. So you can have a cutting width from 3 meters up to 5 meters, and lengths can be from anywhere from 6 meters up to 30 meters also, 32 meters. So you have a table, you can have a plate in the front where you cut. At the back, you have a plate which is already cut, where people can be removing the cut parts and putting a fresh plate. So these machines are that type. This Trophytherm is for application up to 200 amps. The next one is the 𝒔𝒐𝒏𝒄𝒄 Pro. I just took a step before. Here is a machine which has got cutting capability up to 460 amps and 600 amps also. And again, the same way, cutting widths up to 5 meters and lengths up to 32 meters. And here, one good thing is here we can have beveling, that is beveling on each axis. That's a fixed beveling up to 45 degrees on the longitudinal transverse axis. And if you want to do cutting on the contour, we have a non-TCP tool called 𝒊𝒎𝒎𝒆𝒅𝒊𝒂, which can be used. And then comes our flagship machine of the non-laser machine. This is our Element 400, which is a high-speed machine, which has got two configurations, either a maximum speed of 24 or 50 meters per minute positioning speed. So either way, we can use this machine. And all tools are available in this machine. We can have what you can say, up to high definitions we can use. Then you can have the plasma bevel, not the non-TCP alone. We can have the TCP bevel also. And then we can have all markers, plasma marker, inkjet marker, pin marker can be used. And width is up to 7 meters and length up to 45 meters can be had in this machine. And this machine is typically with a helical bevel rack. So the precision of the cut parts is much better and the quality is much better. So just to have a look at the video of the machine. This is the machine. All safety included. So this is the last. So this is simulation of how the eventually returns. So this is can be used for Oxyfuel and 𝒓𝒆𝒑𝒂. I'm just moving it forward. So in this we have a manual bevel like for the longitudinal transverse direction, and we can have the uh, contour beveling application also, wherein we can bevel up to 45 degrees. And one thing is we can change the bevel while cutting also. So you can vary the bevel on the fly. So that's an important thing which is not available in many competitors. This is, I'll just run for a few seconds and then I will skip it. So generally we have a protective suit to safeguard the operator's life. So we have just removed it to show how it works. So this is a TCP bevel. So your bevel quality and the accuracy of bevel increases. So the advantage of this is whenever you have a well preparation. Generally, you start with a heavy fabrication. You cut the part and then take it to another work center where you create the welding edges. So instead of that, we can generate the weld preparation right there while you cut it. So the time for cutting is reduced, and then you don't have to have a secondary operation. Then plasma options like hypertherm or Kelberg. Then this is all about the plasma portfolio. Then we have the laser product portfolio. So we have got two types of offerings with laser. One is the standard format laser machines, and then the large format. Standard format laser machines is for cut plates up to 3 meters by 1.5, up to 6.3 by 2.5. That's what we get in India. So we have got three types of machines: low power, medium power, and high power. So low power machines up to which can handle up to 6 kilowatt. The other one up to 15 to 20 kilowatt. And the high power 20 kilowatt and above, so 30, 40, or 60. And only on the low power, we have got a single table machine. And the other things are all enclosed and safe from radiation. So low power is a bit deep dive into the specification. We have the machines of 3 meters by 1.5, 4 meters by 2 meters, and 6.5 by 2.5 meters. And plate thickness capability will be up to 25 mm. That's why we say this can be used up to 6 kilowatt. The other one is mid power is the same sizes, but the application will be up to 40 mm plate thickness. So it's a more sturdy machine. And we have two options wherein we can have an increased acceleration and increased speed also. So we have this option also, up to 200 meters per minute positioning speed and 2.8 meter G rapid maximum accelerations on simultaneous. And then the high power, similarly here also. But two major differences is the plate holding capacity is still more higher, 60 mm. And then these machines will have thermal insulations because when you are cutting at high power, heat generation is more, which tends to heat up the body structure. So that's the insulation which separates the body structure from the cutting zone. So the stability of the machine structure is not affected at all. So that thermal insulation is available with the high power machine. So these are the three various categories with the sizes on the standard format. Then on the a small video to show you how it looks like. I'll just run for five seconds and then take you to the next product. So you have a machine fully enclosed. Then you have the study table, various study tables which takes the minimum time for exchange. And in our laser machine, we have lasers of IPG, 𝒂𝒂 and 𝒂𝒂. And on the cutting edge front also you have 𝒂𝒂 and 𝒂𝒂. So I'll just run through. So large format is the next type of machines where we talk about cutting large sizes of plates. So on the standard format, we have plates of 3 meters by maximum plates of 3 meters by 1.5, 4 meters by 2 meters, and 6.5 meters by 2.5 meters. But for large format, the cutting width, if the cutting width or the plates to be cut are 2.5 meters and above, or the cutting length has to be 6.5 meters and above, we have bigger machines which we call the large format. In the large format, we have got three types of machines. One is the fixed type, where the cutting width can go up to 4 meters and the cutting length can go up to 28 meters. So you have a fixed table where plates are kept put and you do the cutting, and laser powers can be up to 30 kilo. And the next variant is, and especially in the fixed table, you have a localized enclosure, which I will show in the next coming slides. And for parallel exchange table, it's like you have a shuttle table, but for a longer length than the standard format length, for 8 meters and 13 meters, and which can be from 2.5 and 3 meters. So you have a parallel exchange and a hydraulic exchange also. So one major thing is in these two machines, we can do beveling with laser also. That's a big thing because earlier what I have told was on the plasma. Here we can do beveling with laser also. So this is a video for the large format. We have not put the enclosure so that we can give you a better idea. So this machine, whatever we are showing, that's our global controller. So this is a bevel. And this is the ink step. This is the hydraulic step. So it's a mixture of all the options what we give in this large format machines. So I'm just skipping this and going on to explain the enclosures. So when you have a fixed table, we have two types of enclosures. One is for vertical cutting, which will be very compact. And when you have a bevel, your tool is going to move around and then you need more space. So you have a better, bigger enclosure also with moves along with the gantry while you cut. And when you have a shuttle table, the whole cutting area is enclosed. So we have three choices of enclosure for the machines, which can be considered based on the investment also. And next important thing is the laser beveling. Here, what we proudly boast to say is our bevel tool cuts up to 50 degrees. Whereas all the bevel tools across in the world, they cut maximum up to 45 degrees. Ours cut up to 50 degrees, plus or minus 50 degrees. Okay. And this is the cut quality what you have seen. So just, I don't want to talk much about this. So this is a video to show how it cuts. So this is beveling with laser. So what happens is minimum wastage of material and accurate beveling can be achieved. This is particularly for mild steel. We have challenges with stainless steel where the limitations are there because of the pressure of gas being used. Higher the pressure, we will not be able to get a better edge quality only during beveling. So this is to just showcase the cutting capability. When you cut with oxygen, you can, this is the glossy finish what I was telling. And then quality cut, you mean you will have some feed marks. You can see some feed marks, slightly feel it, but the surface is good. Okay. And mild steel, you can cut with oxygen and also with air. Stainless steel, it is better to cut only with nitrogen, and aluminum also with nitrogen, because otherwise you are, if you cut with air, the other option will be cutting with air, but the oxidation will happen on the cut surface. So this is the quality of cutting with oxygen. This is cutting with oxygen, like
sorry
I
to
said.
interrupt you. Sir, could you quickly sum it up, because we have Mr. Janak also in pipeline.
Okay, 2 minutes. I just. So this is our thing is all our machines are controlled by the Global Connect, wherein we have the best thing. One important feature is job queuing, wherein we prepare everything and keep ready, and the operator has to just press the start button to perform the next operation. So these are all about our plasma and laser cutting machine. I would just want to not to talk about the material handling, because this session is mainly on the cutting technology. Thank you.
Yeah. Thank you so much, Mr. Ravichandran, for that insightful comparison and detailed explanation of the factors influencing process selections. And my apologies, sir. I wish I could give you much more time, because it was really, really interesting listening to you. So, viewers, if you have any question for Mr. Ravichandran, please put it in the Q&A box. That's my request. So while technical specifications provide valuable guidance, actual shop floor experiences often reveal additional considerations that only come from working directly with customers and applications. We will now focus on real-world process selection and application experiences from Mr. Janak Bhuva, who is the Senior GM for CNC business at 𝒔𝒆𝒅 Cutting Systems India. Mr. Bhuva has extensive experience working with fabrication companies and end users across various industries, helping them optimize their cutting operations and improve productivity. His presentation, that is on-field selection of processes, will focus on practical insights drawn from actual customer applications and project requirements. Welcome, Mr. Janak.
Good afternoon, and thank you, Mr. Roy, for giving me this opportunity. And as Mr. Ravi explained, that all three process has its own role and application in industries. And I think, by seeing all these things, you all may be confused, where to use and how to use and how to select this one. So to get the better insight and what industry leader are doing in the field of this particular fabric or cutting, we have some example, or we have some live cases where, these people are putting a lot of effort to select the right process in their workshop. And I will give you some example, real-time example, what we did in last 25 years in this industry, and who are the market leader in their field are doing for the cutting application. We start with the large format laser machine, and mostly this particular models people use in yellow good industry. And this particular example I am showing from the S Construction Faridabad. They are the market leader in crane manufacture and earth moving equipment. You see, we have provided this one in spite of this customer is my customer more than 20 years. We have supplied the first plasma cutting machine in 2006-7 in that industry with very air plasma basic. And today we have a more than 10, plasma cutting machine, and also in the recent year we supply the laser cutting machine due to the changing in requirement, changing in their application, and the requirement of the industry. This particular laser cutting machine is 12 kilowatt with a shuttle table of say 2.5 meter and 8 meter. This one, and they are mainly in, as I said, in a crane manufacture and construction equipment machinery, and they can thickness up to say 25. And their profile, mostly some profile they are suited for the laser application. And very interesting point, I will tell you, it's not the plasma is out or laser is only there, or laser is out and plasma is there. This customer has placed the order both the plasma and laser together on us. So you can understand how they select this particular machine for their application. Some particular components in their overall product goes to the laser, and some product component of that product will go to the plasma, and then they combine both the things and produce their product. So that is the way they go about this.
You have to share the screen.
Mr. Janak, do you have a PPT to share?
Yeah.
Right.
Okay.
Yeah.
1 minute, sir.
Yes, sir. Yes. Screen is visible, sir. You can put it in the slide. So, yeah. Perfect, sir.
Yeah, so that was the machine I was talking about. This particular installation is Edge Construction Faridabad, and as I told you, this customer was having the 7 plasma. He's having the 7 plasma from 𝒔𝒆𝒅, and this 8 plasma and first laser they place the order together. So it's again, as I informed, depend on their application and thickness and the product they produce, they select the cutting application and or say process. This is another example. In Ahmedabad, and that is also, this customer also my 20 years old customer, and they are in customer name earlier it was knowing as a Gujarat Apollo, now is Amman Apollo in Mehsana, and they were using our plasma cutting machine since 2005 and 6, all high definition plasma, and recently they, in spite of having the plasma, they put the laser cutting machine for the new requirement of the industry or their customers, and some export orders where the outside cutting profile get exposed, and they don't want to do any rework or anything. They can directly use from laser. So they have now 4 plasma and 1 laser. So they are using both, as per their requirement, lower thickness, some export job, where there's some quality and get any requirement, or say some accuracy or some small hole laser than the thickness of the plate they use on this laser cutting machine. Another they will still using the plasma 24/7 or 3-4 plasma in their requirement. Another machine in Jamshedpur. This is again basically for the earth moving or say tip and trailer manufacturer parts, and this customer is using the plasma, our plasma, as well as now they started using the laser for 6 kilowatt. And this machine, very interesting. Some application is not like a laser always come in 1.5/3 or 2/4. This is a gantry type of laser, and when you go to the yellow goods industry, most of the time they get the plate of say 12 meter, and to get the maximum yield, if they use the 12 meter plate together, then they find the very good yield in while doing the nesting. And for that reason they go for the very long machine. Here the table size is 3.1/13 meter, so they can put the plate 3/12 or 2.5/12.5 meter plate, and they can utilize the plate as a maximum. And this is a 6 kilowatt, and they go up to 2020. This is the ASL Jamshedpur. Another example of the BEC Billai, where they use both the application in one machine. In here they use the 1 kilowatt laser. This machine we supply around 4 years back, and what was the purpose? They want to cut small hole for the very low thickness. Plasma cannot do, because plasma has a limitation. They cannot go and do the good quality of hole in lower thickness, or say less than plate thickness. So here they use the 1 kilowatt power source to cut the holes, and immediately after cutting the bigger profile or bigger profile on their plate, they use the plasma, because plasma they find more faster and more this one as compared to this one. So that's the reason this is we call it combo machine, where the one laser and one plasma sitting on the same gantry. This is another example in South India. Is Tirupati, and they are maximum. They are in a pipe manufacturer. They also have one plasma, and they procured the laser cutting machine. Again, is 3.1 by 14 meter length with the 8 kilowatt IPG. They are cutting 22 MS plate mostly. If you go to the again Bhilai industry, the second machine, they are producing the railway bogie frame and loco shells and cutting of say 12 and they are using the 3 kilowatt IPG power source with the 3.1 by 8 meter single table machine. And this particular customer also have a plasma of ours 260 amperes. This is the large format machine. This is a job shop, and particularly when the people have a job shop, they have a variety of cutting thickness coming in. So sometimes if you buy the any capacity of machine, next day the customer come with some extra capacity. So this customer is having the plasma as well as the laser to serve their customer. And laser they use for typical requirement of their customer, and their plasma they use for this one. So I mean to say that in plasma or laser is today's requirement. Both are the necessary for the fabrication industry, and most of our customer or most of the our client are having both the process, and depends on their requirement. We have some cases after using the 5-6 laser machine in maybe 4-5 years, and today we sold one machine recently in the Rajkot. They are using the 6 Amada machine, and now they wanted the plasma machine. You can see that everybody say plasma and laser is coming in. Here the laser they were using for 6 years, and then they bought the plasma machine to meet their requirement for higher thickness and other application point of view. Here is another machine as the large format in Polyhouse Chennai. They are the yellow goods supplier for the 𝒊𝒂 and other Lib boys and other Japanese this one client, and they have a two actually. This is the first time they procured, and after that they procured the second machine also for the 6 kilowatt, and they are using this laser cutting machine. Apart from this machine, we have supplied 2 plasma bevel machine for doing the edge preparation for the higher thickness. So this is from Polyhouse Chennai. This is the large format machine is 𝒓𝒆𝒑𝒂𝒍, and as I said, this also my very old customer, more than 20 years. They are using the plasma, and last 3 years back we supplied the one large format laser cutting machine with the 12 kilowatt capacity, and they are cutting up to say 25 continuously for their application. Apart from them, they are also using the plasma. This is another machine at Raipur is recently supplied. It's a 30 kilowatt laser cutting machine, and that is a PEB, Apollo tubes in PEB sector, and they are going to produce the PEB for the industrial this one. So we have supplied the 2 machine there and the length is for this machine is 32 meters. So they can accommodate the 2 plate in this one. So and also we have supplied this customer in a surprisingly Oxyfuel machine for the cutting the higher thickness of say 40 and above for the strip cutting. This is the machine from Chennai, and again it's a swing setter. They are in yellow goods and concrete mixers manufacturer, and we have supply. Also, they were having the 2 plasma from our side, and we supply recently the 3 laser machine, one in 𝒓𝒆𝒑 area and 2 in a Chennai plant for their requirement. And this is the transformer tank manufacturer Sigma Heavy in Bhopal, and this customer is we have supplied a 10 kilowatt IPG power source with you can see the length and width of the machine 3.6 meter up to 14 meter table size. They can use it with this machine. And this is the last. This is our premium customer, and it's a multinational company located in Pune and Baroda. They are the light pole manufacturer company called Walmart. They have a 3 plasma machine from our side, and recently they procured the 1 laser cutting machine length up to say 26 meter table width and length, and for their Baroda plant, and they are using both. And after this machine, they again procure 1 plasma machine. So as I said, it's a depend on your application, depend on your job mix, or depend on your product requirement in your shop floor. People are choosing the plasma, and so you have to choose or say inform your decision while making these decisions. Thank you very much from my side. Thank you.
Thank you very much, Mr. Janak, indeed, for sharing those valuable insights, practical recommendations, and a very few of your success stories. I know 𝒔𝒆𝒊𝒈 has achieved many success stories in this Indian market as well as global market. So we now move to the Q&A segment of today's workshop. I'm extending this session by another 10 minutes or so for the Q&A. So we have received several questions from our audience, and I would like to thank everyone for their active participation. So I'll invite all our speakers to switch on their audio and video and address some of these questions. So I also invite Mr. Prem Kumar. Mr. Prem Kumar, can you switch on your video?
Yeah. Yes, sir.
He's the DGM R&D and Product Management at
Yeah.
Mr. Cutting Systems India, and he's specially joining for this Q&A session. So let's take quite a few questions. There's a question from Mr. 𝒓𝒆𝒑𝒂𝒍. He's asking, does material of plate matters while considering cutting capability? I think Ravichandran sir already spoke about that. Ravi sir, do you like
Yes, definitely. The material plays an important role. So you are talking of type of material, right?
Yes, sir.
So if it is mild steel with higher thickness, obviously your choice will be Oxyfuel. And all the other cases like material in terms of mild steel or stainless steel or aluminum is good for laser or plasma. But you have a beveling to be done with a stainless steel, then plasma will be a better solution. So, and also the cutting speeds versus thickness also matters. So it is type of material with thickness as well as what job you have to do and the level of productivity you need. It decides what to use.
Right. And Mr. Suman Karmakar is asking, which kind of method will create huge impact in terms of heat affected zone? Yeah, very crucial. And can affect the material property and crystal structure. If material property is highly concerned with, method is suitable. So if you can talk about that. That is in the Q&A box, the second question.
Yeah, Ravi, he's talking of HAZ. I mean, heat affected zone versus all the three processes.
Yeah, heat affected zone, because of the higher curve, Oxyfuel will have the higher heat affected zone, whereas there will be reduction with plasma and very minimal is the laser, because cutting curve itself is around less than 0.5, 0.4 mm. So heating also is very concentrated.
Right. Mr. Ajay Bole is asking, he's from Viprapari, I think. He's asking that I'm planning to refurbish my plasma cutting machine. Could you please suggest the best retrofit or refurbishment options and service providers? So Prasant sir,
Okay. I will reply to that. We are doing it retrofitting. We need to know whether it's a messer machine or non-messer. Both way we can do it. If they can send us the specification or say maybe location, we can send our people to assess the situation there and what kind of retrofitting they want. They want to put update the controller or say update the plasma or update the table or whatever it is. It's possible to do it, once we assess the situation at the ground level. Yeah, it's possible.
Yeah, and as rightly said by Janak, just connect to us and with all the pictures and your present configuration. And we have team across India. I shared even the location. So immediately the person will get in touch with you and give you and then we will also access your requirement exactly. You need improved cut quality, you improved cutting thicknesses, or you need productivity more, or you're looking at more environment solution in terms of reducing the flames and all that. So all combinations and the whatever best for your investment can be given. So very much we will be supporting you for that.
Mr. Mayank is asking, if I'm been able to read that question properly, that the features of 3 kilowatt machine and asking about the weight and final, it's in the chat box.
Maybe a 3 kilowatt 3015 machine, Ravi. What would be a tonnage? Means he's in terms of the weight of the whole setup.
It will be somewhere around 8 to 9 tons.
It's again depend. It's a shuttle table, without shuttle table, enclosure, and all
generally
stuff.
we prefer to sell machine with enclosed machine with shuttle table, unless otherwise if there is space is less where people have to have only a machine, not the shuttle table. So generally, a machine with shuttle table will be around 9 tons.
Yeah, and sir, maybe you can, what you can also do is you can, because we are running out of time, so we are taking them a little quickly.
Right.
Even your questions, if you feel they are not totally answered, either through Mojo connection, email, or through Messer, just do write to us and we would be connecting you and giving you a little bit more deliberate and reply on that.
Right.
At the same time, the point of enclosure came. So I would just like to add that all dear customers, users, kindly remember that laser is highly detrimental because of the intensity of the arc. So do not compromise on safety, and always remember that enclosed machine, or at least the enclosed systems, are important for you to the best possible. Kindly avoid the open machines which are available in the market at very low rates and all that, for safety of eyes of your employees, operators, and even the senior people who are passing by the machines during inspections. Even it is detrimental to the cornea and other parts of the eyes. So that's just a passing by comment. Thank you.
Very, very important suggestions made by Mr. Prasandina. Mr. Vijay is asking, in laser cutting based fabrication is how much important, and please suggest required weight for a 3 kilowatt dual pallet.
Maybe you can just repeat it.
In laser cutting based fabrication, how important in laser cutting base fabrication is how important is the base fabrication, and please suggest the required weight for 3 kilowatt dual pallet.
This fabrication, if you see, that's the base of our machine, stability. So what we normally do is we have the stresses induced due to welding are all should be relieved, and when the final machining is done, it should be stress free. That is one to talk about the base of the machine, not just a 3 kilowatt. It's for all the machines. And regarding the weight, I have already told we can't specify for the base so much. That's a very intellectual property of ours. So the total weight of the machine will be approximately around 9 tons. That's all we can specify.
There's one more question from.
Yeah, but that I would, Subhajit, I would like to add on that. If I can understand the question, that how base is very important.
Right.
I think that's extremely right what Ravi said. Sometimes, as you know, the market has many machines, including the economic one, Chinese one. Sometimes it is considered that Messer machines are a little expensive and people find that, oh, this is so cheap. But anyway, the base is the frame, the whole structure is extremely important for the longevity of the machine. Otherwise, we can always make a lighter base frame, and then we can make it economic. But what would happen in 3 years, 4 years down the line, there would be warpages coming, the thermal stresses will relieve themselves, and then the machine dynamics will get disturbed. So you will not get the right cut quality, you will not get the alignments, the accuracies will be disturbed. Whereas Messer puts in a lot of time, and we even don't offlet our stress relieving. You have seen, Subhajit, yourself, that the whole process is so streamlined and it is so controlled that we have a complete furnace for stress relieving, and we do it indigenously and do not get it done even from outside, because we do not have control on that. So base frames are extremely important for these machines, for their longevity, to maintain the accuracy levels and all. That's how Messer machines are running for 18 years now. And not for laser, even for plasma, we have the same level of...
even laser, in laser, one 500 first machine in Mehsana, we supply around 8 years now. And it's very simple machine, it's still running, it's 500 watts, 500 watts first machine.
Wonderful.
Yeah, 8 years.
Excellent. Yeah, so
that smile says everything, sir. Mr. Suman is asking one more question. I think we are looking for, Mr. Suman is looking for piercing of hole up to 25 mm. Yeah, both MS and HT material. So which model is suitable for this? And these plates will be used in transmission line, for power transmission lines. So Janak sir, if you can take that.
Yeah, it's a transmission. You want to do the accuracy of the hole. I understand this one. Mostly, it's a laser is a suitable, but a lot of people are doing. I think they use for the bolting of that plate. Then both plasma, high definition plasma also sufficient for your requirement, because we have a transmission like 𝒊𝒂𝒂, Karamtara. We have a lot of where we supply the plasma machine for years together, and EMI is not an international transmission, and the KEC. So these are our key customer in transmission line, all of having the plasma cutting machine, but definitely high definition plasma. Yeah.
And Mr. Chirag is asking, is at all we are using AI tools for laser or plasma cutting process?
That's the AI tool, artificial intelligence. He's referring.
Right.
How Ravi and Prem has any AI entered our machines? Can you?
We are not using for cutting parts, but for our regular work only we are using.
Okay. So there is one more question.
But as such, the selection in our controllers and our systems, you just select the the cutting thicknesses, and rest of the parameters.
Yes,
the
everything is taken care of.
It is taken care of. So it is sort of an automation, but definitely not an directly AI influence at the moment.
Okay, so Mr. Devang is now sharing a very practical problem what generally people face, that with cutting edge technology, cutting speed and quality is not an issue, but loading and unloading is a big problem. So how it is resolved, because we cannot fully utilize capacity. So Mr. Prem, if you can take that question, if it's relevant to you.
Yes, sir. For the material handling part, we can say the basic machine, we have the options like 𝒂𝒂𝒒. We have mentioned about the parallel exchange. One option for customer that they can load the plate, and this exchange will take care from the automation side. So our own controller from the Germany is fully equipped to handle this transition of parallel exchange table. But if also we have another option to make the plate cutting with hydraulic system. So the movement of the table will be from up and down. We have cylinders in each place. It depends upon the machine's configuration. So there will be a smooth movement from the up, and it will push into the machine for the cutting area. And once the cutting is done, it will be taking away from the machine. So this is also two options basically we have for material handling. And if you want an integrated automation solution, we are the one single provider. We can integrate our basic machine with the state-of-the-art material handling system. So where we can handle a lot of plates staggered together in a big tower, and this can be moved to the different machines in the floor. So we have a very big installation done in Chennai, and it is fully operational now. And you can contact our sales team. We can have a quick look on the full automation process, right from the loading to the cutting and bringing back the systems after the cutting process. So that's it's a very
I would like to bring in
Ravi, quickly share that image of material handling. Your last slide, Ravi.
And for the audience, for the delegates, if you have any question, immediately after this session, you will be receiving a feedback email. So please share whatever inputs you have. We will be sharing the same with the MESA team.
Can I take a few minutes?
Yes.
Quick. By the time you will be done, Ravi, share.
Right. That was the reason I was taking time.
Okay.
You can.
Thank you. Just a moment. I would like to.
You can show it, sir. You can show it if you want.
Yeah. As rightly asked by the customer, many times we just focus on the speed of the machine. I want higher speed. But when we actually go on the field, we see that the machine cuts with a very high speed, but then sits idle for many time for loading and unloading.
No, 2 hours. 2 hours is sitting idle.
The crane operator is not in place. He has gone for lunch. He has gone for a tea break, and the machine is sit. So it's like it runs fast, then stands. It runs fast and then stands. So finally,
wait for the plate. So that's it.
Right.
So yeah, we have two types of automation systems. Like we have a whole range of solution, right from storage to transferring plate from the machine storage to the machine area. Then from there, feeding onto the machine. Then after that, from the machine, picking up the cut parts and also sorting them. So we have two types where the pictures show that what I'll just typically these are the storage towers. This is the loader, unloader, and this is the machine. We have two types. One has the separate loader, unloader for bigger machines, and one is a combined loader and unloader. So this we have done up to plates up to 7.5 meters by 2.5 meters. One single plate of 5 ton, which can be loaded onto the machine, and then it can be cut parts can be unloaded. So just to show our portfolio has all these elements, like, so it is direct from plate to machine is what people are doing, right? Either by crane or a forklift. We can have intermediate storage parts, and from there we can pick up the plate using a vacuum lifter and load on the machine. Then after it's cut, although the cut parts are scooped at one go and then are dropped onto the another place where you can do the sorting. And we also have sorting machines which can automatically sort it. So, and we have another single, like you have a machine of size 3015 or 4020, a compact one which is typically for one machine application, which occupies very less space. So you have one operator, you put a bundle of plates, you don't have other helper or associate to help them feed the plates, and this will help you utilize your machine 24/7. So
Right.
this is
Ravi,
one.
you can just go to the last slide of,
and then the next slide is, this is a big installation which is being done, which is completed. This has got 3 laser machines of 6.5 meters by 2.5 and 2 plasma machines which are cutting 7.5 meters by 2.5 meters. So we have a tower system where it is the plates are stocked for one shift, and from there automatically the plates are fed to the system. No operators handling all these machines. We have got 2 females. The operators are 2 females, 1 female for these 2 laser plasma machines and 1 female for the laser machines. That's how the operator, the customer uses it. And the schedule is done and the whole system runs automatically. The operator is there to monitor, and when the system tells them to change the consumables, they change it. Or else, if there is any troubleshooting in an event of, in case of a small troubleshooting to be done, only in those times they get into the working area. So 100%. So automated, and because of that, the machine runs 24/7. So there is no idle time, no waiting for the plate to be loaded. So nothing is there.
Right.
Yeah,
So,
Ravi, thank
can
you.
you
It's
stop
a
screen sharing,
passionate
sir?
topic for
Right.
Ravi. He can speak for hour on that. So
Yeah.
we will just
Can you stop
hold
screen
him.
sharing, sir? I just
I didn't get you.
right. So generally, what happens is, after every, completing after every webinar, we get a kind of messages from the audiences that they need the recording or the PPTs of the for the presenters. So what we did is we did the live streaming of entire session. So whoever wants to relive or rewatch this entire session, they can go to our YouTube channel, that is Mojo for Industry Media. Immediately we'll find, even now also, that it's being live streamed on YouTube. So it is there for your archival throughout the channel exists, of course. So as we conclude today's live technical workshop, I would like to extend my sincere thanks to MESA team, especially our distinguished speakers, Mr. Prashant Chaturvedi, Mr. Ravichandran, Mr. Janak, and Mr. Prem-Kumar Murugesan. Thank you so much, all of you. So I would also like to thank the delegates who have attended this session and sharing the questions and being so active, and it was very, very engaging session throughout. So today's session has clearly demonstrated that the choice between Oxyfuel, plasma, and laser is not simply about selecting a machine. It is about selecting the most appropriate technology for specific production requirements, quality expectations, and business goals. As each one of the speakers were saying, no, we don't have any ready to go product to just prescribe you. We have to analyze each and every aspect of your operations. Then we will suggest that what method or technology you should adopt. So on behalf of Mojo for Industry and MESA Cutting Systems India, thank you once again for being with us today. We look forward to welcoming you to another insightful industry session very soon. Have a great day and stay connected with Mojo for Industry. Thank you so much. Thank you so much, all of you.
Thank you.
Thank you.
Thank you.